I'm just going to start with mole concept, and I'm going to finish the chapter in my own way as I finish for everyone. Okay, ma'am might have started with law of chemical combination, I know, but what I'm going to do now is I'm just going to start with your mole concept, and only then I'll teach you law of chemical combination. So if she has already started or taught, not a problem. Let it be there. We'll start with mole concept. We'll work out through that way, and we'll come back to laws of chemical combinations. Hope that is okay for you. Correct? Okay. So since you are all grown up, uh, for in the beginning, after or half an hour, I'll give you the mute control to all of you. So if you have doubts, you can ask me. In between also, you can reply in the chat for your doubts. Okay? Fine. So yes, we are just going to start with the chapter. The chapter that we have now is mole concept. Okay? Yes. What is mole? That is the first thing that we have to understand. Okay? We know that 1 mole is equal to 6.023 into 10 power 23 particles. Hope you all know this, correct? 1 minute, let me open PCV. Okay. So we were talking about mole concept. In that, 1 mole is equal to 6.023 into 10 power 23 particles. Correct? Okay. Next, what we are going to see. Has ma'am taught you about mole concept? Was any introduction given about mole concept? I'll just unmute anyone so I can get an idea. Okay, Aishwarya, I'm unmuting you. Tell me what has been taught to you so far. Okay. No, mole concept is not yet taught to you. Okay, anyway. So now just continue with mole concept. 1 mole is equal to 6.023 into 10 power 23 particles. Yes. Why particularly 6.023 into 10 power 23 particles? That is what we have to see. Correct? So why? Because see, just listen here. We know that, for example, let me take one atom of carbon. Carbon's atomic number 6, mass number is 12. So this mass number is because of the protons and neutrons. Okay, this mass number came because of the protons and neutrons, plus neutrons. So we can come to a conclusion that these protons and neutrons contribute for the mass of atom. Yes, they contribute for the mass of an atom. Now, when they are contributing to the mass of an atom, what do I understand from that is, see, listen here. You have protons and neutrons, they are contributing for the mass of an atom, and here if you see here, we could say that the each mass part units are called as atomic mass unit. So here you say the atomic mass of one atom of carbon is 12 AMU. 12 AMU means 12 atomic mass units. It means you have 12 units. So each proton or neutron is called to be one atomic mass unit. Clear? So totally the number of units that contribute for the atomic mass is 12 here. So atomic mass of carbon here it is 12 AMU. Yes, electrons have mass, but it is very negligible. even if we consider it as not going to bring a significant change in the mass of an atom. So we do not consider the electron's mass. Clear? Okay. Now, so the atomic mass of carbon is 12 AMU. What does 12 AMU mean? It has 12 atomic mass units. What are those atomic mass units? Protons and neutrons. Okay. For example, let me take another atom. Okay. So what is another atom? For example, oxygen. Its atomic number is 8, mass number is 16. So its atomic mass will be 16 AMU. For example, I take another element, nitrogen. Its atomic number is 7, mass number is 14. So its mass will be 14 AMU. You all understand this? AMU means atomic mass unit. Good. Now, can I express mass of atoms in grams? Can I express mass of an atom in grams? An atom. Understand? Yes. Okay, my voice is breaking. Is it clear now? Is my voice clear now? Okay, thank you. So can I express mass of an atom in grams? Okay, my voice is not clear. Anshita and Olivia. Some background noise. Okay, let me check that. Okay, anyway, so now listen here. The mass of an atom in grams can I express? Let's just get back to the class. Can I express the mass of an atom in grams? Yes, we can express. So how am I going to express? So listen here. It is 16 AMU, correct? So if it is 16 AMU, I should know what is 1 AMU. For example, I can convert 16 kilograms to grams. 1 kilogram is equal to 1000 grams. So 16 kilogram will be 16,000 grams. Am I right or not? It will be 16,000 grams. Similarly, we could see here oxygen has 16 AMU. If I wanted to convert it to grams, I should know what is 1 AMU in grams. Correct? Here, what is 1 AMU? 1 AMU is nothing but the mass of proton. It represents a proton or neutron. It represents a proton or neutron. Correct? So the 1 AMU you can express in terms of grams, which is nothing but the mass of proton or neutron in grams. So which is nothing but 1.673 into 10 power minus 24 grams. Clear? So mass of one proton is 1.673 into 10 power minus 24 grams. So here it is 16 AMU. So mass of one oxygen is 16 into 1.673 into 10 power minus 24 grams. Similarly, mass of nitrogen will be 14 into 1.673 into 10 power minus 24 grams. Is it clear to every one of you? This is the mass of one nitrogen atom in grams. Just see how small it is. 1 gram itself will be very small. You are going to divide 1 gram by 10 power 24. Only then you get this, right? So it is very, very, very small. Mass, atom size is very negligible and its mass is also very negligible. So now it is difficult for us to measure the mass of atom. Yes, protons and neutrons have identical masses, almost similar mass. That is, if it is 1.673 for proton, for neutron it will be 1.679. That is the only difference. Okay, or 1.69. But basically they almost have similar mass. Not same, but similar, not identical mass. So what happens is, but if you consider mass of proton, electron and neutron, neutron's mass is slightly greater than the mass of proton. Clear? Okay. So we just consider this to be the mass of proton or neutron, whatever. Got it? So this is how we write mass of one atom. Just note it down, then I'll go to the next slide. All protons have same mass, Rajvi. All protons will have same mass. Mass of one proton is 1.673 into 10 power minus 24 grams. Almost the mass of neutrons is also the same. So if you have 15 atomic mass units, its mass in grams is this. That's it. Okay, so now we can come to the definition. What is one atomic mass unit? You might have studied the definition as atomic mass unit is nothing but it is the mass of 1 by 12th the mass of carbon atom, C12 atom. Okay, so 1 by 12 into mass of C12 atom, obviously it will be 12 AMU. That will give you 1 AMU. You can also express in terms of oxygen. If it comes to oxygen, you could say 1 by 16th into mass of oxygen atom. That is also 1 AMU. Clear? Even in terms of nitrogen also you could say. But why carbon particularly in definition? Because carbon is an abundant element. It occurs everywhere. And so we take carbon in count. Clear? So atomic mass unit is nothing but it is the mass of 1 by 12 the mass of C12 atom. Have I made it clear to you? That's all. So this is atomic mass unit. Please note it down. Hope I have made it clear. Shall I move to the next part? Okay, I'm explaining it again. It is the mass of 1/12 the mass of C12 atom. Just now we saw that the C12 atom mass was 12 AMU. The mass of C612, it has 12 protons and 12 neutrons. I'm sorry, 6 protons and 6 neutrons. So you have 12 atomic mass units. So you say it is 12 AMU. So what happens here is, it is the mass of 1 by 12 the mass of C12 atom. That is atomic mass unit. Why? Because 1 AMU definition is that. Because mass of C12 atom is 12 AMU. 1 by 12 means you will get only 1 AMU. So that is the definition that you are trying to say. So with oxygen's mass also you can say 1 by 16th the mass of one oxygen atom. One oxygen atom mass is 16 AMU. So 1 by 16th it gives you again 1 AMU. Have I made it clear to you now? C specifically because the abundance of C is greater compared to other elements. The one of the most abundant element, either in the either in the form of a compound or in the form of an element. They are found everywhere. Rocks, cells, all organic matters. Everything contains carbon. Most of the organic matter contains carbon in it. And also C is stable. Yes. Okay. Now shall we go to the next one? So the next one that we are going to see is atomic mass now. So atomic mass is nothing but mass of one carbon atom. I'm sorry, mass of one atom. Clear? It is the mass of one atom. You can express it either in terms of AMU or in grams. It can be expressed either in atomic mass unit or grams. For example, if you take oxygen, its atomic number is 8, mass number is 16. Correct? So if you express it in AMU, you write it as 16 AMU. If you express it in grams, you write it as 16 grams. I'm sorry, not 16 grams, 16 into 1.673 into 10 power minus 24 grams. Similarly, if you take nitrogen or you can take sodium, its atomic number is 11, mass number is 23. So its atomic mass is 23 AMU or 23 into 1.673 into 10 power minus 24 grams. Hope I'm making it clear. Okay, shall we go to the next part? The next part that we are seeing is moles now. Why particularly mole? Now, just now we saw that the mass of atom is very, 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 very small. It's very negligible. You cannot measure it. So in a laboratory, I'm asking you to measure some 20, I'm asking you to bring some 1000 calcium atoms. I'm asking you to bring 1000 calcium atoms from the laboratory. How will you go and bring? I know mass of one calcium atom is hmm, 20 into 1.673 into 10 power minus 24 grams, because atomic mass of calcium is, mass number of calcium is 20. Now, if I wanted the mass of 1000 calcium atoms, what will I, 1000 into 1.673 into 1000 into 20 into 1.673 into 10 power minus 24. This is very, very small, correct? Very small. This you cannot measure. This you cannot measure. Sorry, mass number of calcium is 40, not 20. So 40 into 1.673. So here also you have this. Though you multiply it 1000 times, the mass is still negligible. It is 40 into 1.673 into 10 power minus 21 grams. It's still negligible. It's very small. You understand what I'm trying to say? So what we are going to do here, what should we do here? So what we do is we try to calculate the mass of some group of atoms. For example, when they calculate the mass of in a chocolate company or in a toffee company, the mass of one toffee that they make is 1 gram. Okay. Now what they are going to do is, if they have to pack uh, 10,000 packets of toffee, each packets contain 1,000 toffees. Okay, so how are they going to pack it? So they need 10,000 packets, and each packet should contain 1,000 toffees. Will they count and pack? Contains 1,000 toffees. Mass of one toffee is 1 gram. Someone has raised hands. Who raised hands? Aishwarya. I'm unmuting Aishwarya. Tell me. Okay, fine. So each packet contains 1,000 toffees, correct? So how are you going to do that? Okay, not a problem. So if mass of one toffee is 1 gram, what will you do? I need 10,000 packets. So one packet should measure 1,000 grams. So I'll measure 1,000 grams and I'll pack 10,000 packets. Am I right or not? This is what I'll be doing. So same thing I'm going to do here. Same thing I'm going to do here now. Okay, yes, by knowing the mass of 1,000 toffees. So now here also what I'm going to do is I'm going to standardize the mass of atoms. I cannot calculate the mass of one atom or 10 atom or even 10,000 atoms. Measuring the mass of 10,000 atoms in the laboratory is also difficult because it is very negligible. So what I do is I'm just going to standardize the mass of atoms for some certain number of atoms. How? For example, let me take sodium. Sodium's mass, one mass of one sodium atom is 23 into 1.673 into 10 power minus 24 grams. Now I am just going to multiply it with some number of atoms. Okay, so that the mass that I'm calculating will be, for example, if I'm putting 100 atoms here, I'm going to have name the 100 atoms, like I can even say 1 mole is equal to 100 atoms. Okay, so suppose if I'm putting 10,000 atoms, uh, now 1 mole I can have 10,000 atoms. That will give you the mass of 10,000 atoms here. Do you understand what I'm trying to say? I'm repeating again. I'm having an atom called sodium whose mass number is 23. Mass of one sodium atom is 23 into 1.673 into 10 power minus 24 grams. Clear? Now I'm going to multiply it with some number of atoms. I'm going to multiply it with some number of atoms, so that what will happen is I'll get the final answer here. That will be the mass of these many number of atoms, correct? Mass of these many number of atoms that I'm going to enter here. Okay, for that number, for example, for 1 dozen, I give it 12, correct? So if I take 1 dozen of atoms, here I'll multiply with 12. So, and the final answer that I'm getting will be the mass of 1 dozen of atoms, correct? Similarly, if I'm going to take, give some like 1 ream, let it be 100. So if I'm going to take 100, this will mass of 1 ream of atoms I'll get. But mass of 1 dozen of atom will be different from the mass of 1 atom, correct? So now what happens, I need to remember the mass of 1 atom separately and mass of 1 dozen of atom separately, which is quite difficult for me. Every time I ask you for the mass of 1 dozen of atom, you'll have to sit and calculate. Am I right or not? And also mass of 1 dozen or mass of 1 ream, 100 atoms are all very small, very, very negligible. Okay, so now I'm thinking of one thing. Here in this place, I'm going to multiply it with some number of atoms. So I get the same value. I get the same value. What is the value is, I should get the answer as 23 grams. Can I do anything for that? I'm going to multiply the number of atoms that I'm going to multiply should give me the answer as 23 grams. So what number should I multiply here? Very good, Mohana. Very good. Mm, that is what is the mole number. Good. So what I'm going to do is I'm just going to multiply it with the reciprocal of 1 by 1.673 into 10 power minus 24. Okay, this 1 mole is equal to, I'm giving the name for 1 by 1.673 into 10 power minus 24 as 1 mole. Okay, if you solve this, what you will be getting is 6.023 into 10 power 20. So these many number of particles is called 1 mole. So whatever might be the atom, whatever might be its mass. So mass of one atom and mass of 1 mole of atom will have same value but different magnitude. Understood? They have same value but different magnitude. First note down this, I'll explain again. Those who have doubts can raise your hands. Why I want 23 grams only as the answer? Why? Because it will be simpler for remembering also. Because mass of one sodium atom is 23 AMU. If I get mass of 1 mole of atom, if I wanted to get the answer, if I get the answer as 23 grams, it will be easier for me, right? So mass of 1 mole of atoms and mass of one sodium atom will not be much, there won't be much of a difference. Apart from 6.023, if you are multiplying with some other number, for example, if I consider 1 mole as some 6.02 or 7 into 10 power 28, suppose if I consider 1 mole as 7 into 10 power 28, if I multiply with it, the final answer that I'm getting will be different. So mass of 1 mole of atom and mass of one atom will be totally different. You understand what I'm trying to say? I cannot remember, keep on remembering both of them. It is difficult for us also. So why to complicate it that much if you can do it in a simpler way like this? If you divide 1 by 1.673 into 10 power minus 24, you will get 6.023 into 10. 1 by 1.673 is approximately 5.5, 5.9. Actually, 1.673 is will not stop. It's approximately 5.9. It's almost 6 only. No, here you are not giving 6.9, 6.0. So approximately you will get this value. This is the exact value that you will get. Clear? Okay. Now again I'm explaining for some other atom. For example, let me take an atom called magnesium, whose atomic number is 12 and mass number is 24. Okay. Now the atomic mass of sodium is 24 AMU. Correct? Now the mass of magnesium in grams is 24 into 1.673 into 10 power minus 24 grams. Clear? Now what I'm going to do is I need to get the final answer as 24 grams. So with this I'm going to multiply some number. That will be 1 by 1.673 into 10 power minus 24, which is nothing but 6 points. So with 1.673, if I multiply 6.023 into 10 power 23, you will get the same 24 here. So mass of magnesium is 20. So this is atomic mass, that is mass of one atom. This is molar mass or gram atomic mass, which is nothing but mass of 1 mole of atom. Hope I have made it clear. Clear? Just note it down. Okay. Rajvi, can I unmute you? Rajvi, kindly unmute yourself. Aishwarya, kindly mute yourself. Rajvi, kindly unmute yourself. Rajvi? Okay, whoever has doubts can ask your doubts now, up to whatever I have taught. So few of you have asked your doubts in the chat. If you have doubts, please ask. Let's make the class bit interactive. Don't feel shy. Try to interact. Yes, Guru Varshini? Ask your doubt. Guru Varshini? Kids, you have to interact a lot. Okay, my class will be like this. You have to talk to me. Only then I can understand what doubt you have. Interact as much as possible. Yes, Olive?
Ma'am, in the case of atomic mass unit, we wrote for carbon atom. So can we say that it is atomic mass unit of carbon? And in case of oxygen, and we can say atomic mass unit of oxygen?
No. Not like that. See, 1 AMU is nothing but either proton or neutron, correct? So oxygen has 12 protons and neutrons totally. So you say it as 12 AMU. Protons and neutrons is not different for each atom. You understand? It is same for all the atoms. So,
Ma'am, I'm Guru Ashini.
1 minute. So if it is 16 AMU, you write it as 1 by 16. Clear? Olive?
Yes, ma'am.
1 AMU is 1 by 16 the mass of oxygen atom or 1 by 12 the mass of carbon atom. Yes, Kurosh, ask your doubt.
Ma'am, in 1,000 calcium atoms in multiply 1,000, ma'am, why the power will change?
Obviously, it will change. 1,000, 1.10 power minus 24 into 10 power 3. What do you get?
Okay, ma'am.
Next. What else doubt do you people have?
No, ma'am.
Okay. Any more doubts? Hope there are no doubts. Okay. Fine. Kids, mute control is with you. Now, do not unmute you. unless and until I ask you questions, or if I ask you to ask your doubts. Okay, have it with you. Molar mass is a formula unit mass. Okay, we'll look about that soon. Now listen here. So 1 mole is nothing but it is just the number of particles. It's not related to mass or anything. So what we have calculated is 1 mole is 6.023 into 10 power 1 by 1.673 into 10 power minus 24, which is nothing but 6.023 into 10 power 23. Clear? That is 1 mole. And here this 24 grams is the mass of 1 mole of atom. Correct? So mass of 1 mole of anything is molar mass. And mass of 1 mole of atom, you call it as gram atomic mass. Clear? So gram atomic mass is nothing but mass of 1 mole of atom. Okay. If you have donuts, the sweet they eat. So if they wanted to calculate the mass of 1 mole of donut, you can even say it as gram donut mass. Nothing wrong in it. Okay, so mass of any number of moles of substances can be calculated. I can calculate the mass of 1 mole of anything. 1 mole of water bottles. I can calculate the mass of 1 mole of matchsticks. I can calculate the mass of 1 mole of laptops. Anything I can do. Why don't we use 1 mole? So dozens we use in our day-to-day life, like 1 dozen of apple, or we say 1 dozen of pencils, we say. But we don't use this mole concept in our day-to-day life because the number is more. 1 mole is not very small quantity. 1 mole is 6 hexillion number of particles. 1 mole is equal to 6.023 into 10 power 23. That is almost 6 hexillion number of particles. Clear? Which is much greater. So we do not consider mole in our day-to-day life. You all understand what I'm trying to say? So gram atomic mass is nothing but mass of 1 mole of atom. Understood? Now I'll give you a few questions. Just solve. Okay. Let me take an atom called aluminium. Its mass number is 27. Can you tell me what its atomic mass in AMU, in grams, and gram atomic mass in grams? I may ask anyone. Those who have finished can raise your hands. Also, finish the other blanks also. There I have given you 3 blanks. Okay, 2 participants have raised their hands. Yes, Vittal, you can unmute yourself.
Atomic mass will be 27 AMU.
Good.
And gram atomic mass will be 27 grams.
Wrong. Gram atomic mass will be 27 grams. What will be the in between this one? Atomic mass in grams.
Ma'am.
Who answers this? Anyone else?
Ma'am.
Yes, Guru Vashini.
Ma'am, 27 into 1.673 into 10 power minus 24 gram.
Very good. We should know the 27 AMU to gram we have to convert. So I should know the mass of 1 AMU. That's it. Mass of 1 AMU is 1.673 into 10 power minus 24 grams. Clear? That's all. Hope you all understood. Anyway, I'm giving you another one example. Mass of an atom is 24 into 1.673 into 10 power minus 24 grams. Calculate atomic mass of that atom in AMU and in grams. I'm sorry, and mass of 1 mole of atom in grams.
Ma'am,
Yes, tell me.
I'm Nitya, ma'am. Atomic mass is equal to 24 AMU.
Mm.
Mass of 1 mole of atom is equal to 24 into 6.023 into 10 power 23 gram.
No, you are making a mistake.
Okay.
But good attempt. What's your name? Subhashri, right? Okay, good, Subhashri. Thanks for the attempt. Very good. Almost was right. A small mistake you made.
Ma'am,
Subhashri, mute yourself.
not Subhashri.
Oh, who talked now? Okay, anyway. Subhashri, now if you have your answer, you can say. Oh, Nitya talked. Okay, Nitya, mute yourself. Yes, Subhashri. Do you have answer? 24 AMU is right. What is the second one?
Second one, 24 grams, ma'am.
How?
Because 24 into 1.673 into 10 power minus 24 into 1 by 1.673 into 10 power minus 24.
1 by 1.673 into 10 power minus 24 is nothing but 6.023 into 10 power 20. Good. Very good, Subhashri. Now, the mistake that you made, mute yourself, Subhashri. The mistake, Nitya, that you made is, see, listen, 24, what you did is, you said 24 into 24 AMU you had, into 6.023 into 10 power 23. If you multiply, you will get the final unit of mass only in AMU and not in grams. You understand? So this is the mass of one atom in gram. If I multiply it with 100, I'll get mass of 100 atoms in grams. If I multiply it with 12, I'll get mass of 12 atoms in grams. Here I'm multiplying it with 1 mole, that is 6.023 into 10 to the 23. So I'll get the mass of 1 mole of atoms in grams, which is nothing but 24 grams. Hope I have made it clear to every one of you. Did you all understand? Good. Good. So most of you have given the answers. Now, so we understood the definition of mass of one atom and 1 mole of atoms, correct? Similarly, you can also calculate mass of one molecule. Mass of one molecule. So for that, first we should remember atomic mass of few atoms. Clear? So you have C612, O860, Mg1224, sodium 1123, Al27, chlorine 35.5. Then you have your sulfur 32, like this. So for certain atoms alone, it is necessary that you will have to remember the mass. Not only sodium, also potassium, calcium. So mass of one carbon atom will be 12 AMU. Mass of 1 mole of carbon atom will be 12 grams. The value is alone same, magnitude is different. Definitely 1 gram and 1 kilogram is not same, correct? But the value will be same, but the quantity is different. Similarly, 12 AMU and 12 gram is definitely not same, but the value is same, quantity is different. Okay. So here mass of one oxygen atom will be 16 grams. I'm sorry, 1 mole of oxygen, 24 grams, 23 grams, 27 grams, 35.5 grams, 32 grams, 39 gram, 40 gram. Okay, these are all few of the mass, atomic masses of certain atoms. Clear? Now, I'm just going to move to the molecules part. Before moving into the molecules, I'll just ask you, hope you all have copied down this. Hope you all have copied down this. Okay. Okay. Now we are just going to go to the next part. The next part is nothing but I'm just going to ask you the question. The question is simple. What is the mass of 0.2 moles of magnesium atom? You can refer the 14th slide also. Good, good Jayadashini and Hema Satya. Very good. No, Vital, it's not right. No, Pranav, it's right. Good. Elilan, you have made a small mistake. Pranav, again you made, Pranav Kumar has done a typing mistake, I guess. Olive, right. Good, Olive. No, Nitya, the answer is not right. Okay, now I'm just going to explain you. Just listen here. Uh, this is all physical chemistry topics, mole concept, calculations that is dealing with the chemistry, thermodynamics or equilibrium. All these chapters are all physical chemistry. So in physical chemistry, when you wanted to solve a question, so basic thing that you have to remember is you don't use very complex mathematics in chemistry, even in JEE means, okay? We don't use complex mathematics. The only thing that we use is Bode-Mass rule. Okay, addition, subtraction, multiplication using the bracket rule. That is very important. And the next important thing that we'll be using is, apart from Bode-Mass, ratio proportion. I think you all know direct proportion, inverse proportion. If, for example, you might have studied, if 10 workers need 100 kg of food, what is the amount of food required for 5 workers? It is a direct proportion, because if number of workers increase, the amount of food also increases. So from that direct proportion, you will directly calculate the answer. Similarly, here also, we will see for proportion. What are the two quantities that we have compared here? One is mass and the other is moles. First write down that. Moles, mass. What they have asked you? They have asked you the mass of 0.2 moles of magnesium. Correct? So compare. What is the detail that you know about moles and mass for magnesium? I know mass of 1 mole of magnesium atom. That is 24 grams. So mass of 1 mole of magnesium atom is 24 grams. Correct? Now it's simple. I know mass of 1 mole of magnesium atom. Mass of 0.2 moles of magnesium can be easily calculated. Definitely when number of moles increases, mass increases. So it is a direct proportion. So you write it as 0.2 by 1 equal to x by 24. So x is equal to 24 into 0.2. So the answer that you will get will be 4.8. Hope you all understood. How many of you have doubts with this? Okay, very good. Now, Now, next thing that we are going to see is same thing. What is the number of moles of sodium atom present in 2.3 grams of sodium? So sodium's atomic number 11, mass number is 2. Good, Pranav. Good, Jaydarshini. Good, Elilan. Do the same method. What are the two things they are comparing here? Number of moles of sodium atom present in 2.3 gram. So 2.3 gram, they are asking how many moles you have. So you have to compare your mass and moles. Correct? So mass of 2.3 grams of ethana moles, that is the question. Correct? So what do you know about moles of mass of sodium and moles relation? I know mass of 1 mole of sodium, which is nothing but here one sodium atom, if it is 23 AMU, 1 mole will be 23 grams. So it is 23 grams. So I could write it as 2.3 by 23 equal to x by 1. So x is equal to 0.1. So 2.3 grams contains 0.1 moles. Clear? Guru Ashwini, is that clear to you?
No, ma'am, I'm not clear.
Why not? Which thing don't you don't understand?
Ma'am, why put X, ma'am?
Read the question. What is the number of moles of sodium present in 2.3 grams of sodium? Correct? So first the quantity they are comparing is mass of. Am I right or not?
Yes.
So we are going to see the number of moles present in 2.3 grams of sodium. So I have the mass of sodium, but I do not know what is the number of moles present. Correct?
Okay, ma'am. Okay.
So we find it as X. Clear?
Oh, yes, ma'am.
Thank you. Right. Similar to finding the mass of 1 dozen of sodium. For example, I am telling you one apple weighs some 10 grams or even 100 grams. One apple weighs 100 grams. Okay. Now, what I'm going to do is, I'm just going to see, I'm asking you, what is the number of dozens of apple present in 600 grams? Correct? This is what I'm asking you. So they are comparing between number of dozens and mass. So mass and number of dozens. For 600 grams, I need to know the mass. Correct? I need to know the number of dozens present in 600 grams. I know 100 grams, that is one apple is 100 grams. The comparison is between only dozen and mass. So I need to at least find out mass of 1 dozen of sodium, 1 dozen of apple, which is nothing but 1200 grams. Now I can calculate mass of 600, number of dozens in 600 grams, which is equal to 600 by 1200 equal to x by 1. So x is equal to 0.5 dozens. Hope I have made it clear to you. If in that way, similar to dozens, we are going to take moles. That's it. Have I made it clear to you?
Ma'am, instead of this step, can we use given mass by molar mass?
The formula is right. Okay, but I don't prefer formula in the because when you go for questions in NEET or JEE, you cannot prefer or go for formulas. Okay,
Okay,
now
ma'am.
we have derived our own formula. Now listen here. When we found out number of moles in the previous question, where is that question? Yes, here we found out number of moles, correct? See, X was the number of moles. So number of moles, how did we calculate? 2.3 is the given mass. 23 is the molar mass. So we did number of moles is equal to given mass by molar. Only from this they found out this formula. Okay, so do not rely on the formulas. At least for now, you're not going to write any public examinations, or you're not going to have any board examinations based on what I'm going to, the concepts that we are teaching now. Am I right or not? Now you're not going to write anything. So, and foundation, you're not going to face any board examination. So try to be open. Do not stick to a particular rules and regulations, making use of formula, applying it, writing the answer. Please do not do that. Feel free to think. Okay. This way you will know how to solve questions. This will make you solve more number of questions in chemistry. Okay. In the beginning, you might find it a little difficult, but once you get used to the way I'm teaching you, it will be very easy for you. Okay. So you will nowhere rely on the formulas. Do not rely on the formulas. It is never a good idea. You derive your own formula to solve a question. Okay, first solve it, then you find out the shortcut. Okay, if I put given mass by molar mass, I'll get number of moles. How did I do that? First I did ratio proportion, I found out the answer. Now I need a shortcut to solve my questions faster, so I derive my own formula. Okay, do not rely on the formulas first of all. Okay, do not even think about formulas while solving mole concept. Clear? So that's all for today. I have taught you about moles. If you have any doubts, you can ask. You can unmute yourself, Rajvi. Mute control is given to you.
Ma'am, I am Rajvi.
Yes, Rajvi.
Ma'am, at first you said one atomic mass unit is the mass of one proton or one neutron.
Hmm.
Then next you said it is the mass of 1 by 12 mass of the C12 atom. It's very confusing, ma'am. I
No, no,
cannot
no.
understand.
1 minute, 1 minute. It is just a definition. The definition that they give in your book is 1 by 12, the mass of C12 atom is 1 AMU. Clear? You understand?
Yes, ma'am.
You don't have any confusion here. And 1 AMU, if I wanted to express in grams, what is the definition that I have to write? Or what is the conversion that I have to make? For that, I just go see for the mass. 1 AMU is nothing. See, 1 AMU represents proton or neutron. Clear? Rajvi, is that clear to you?
Yes, ma'am. Yes, ma'am. Okay.
So, if I wanted to convert to gram, it's very simple if I know the mass of proton or neutron, which is 1.673 into 10 power minus 20. This is for conversion purpose. This is just a definition. Clear?
Oh, okay. Okay, ma'am. I understand.
Nowhere you are going to make use of this. You only make use of this in the questions also. For 10th standard or 9th standard NCRT, 1 mark or 2 mark definition, if they ask you, you should be able to write this. But nowhere we are going to use this in the formula. This only you use. Clear? Or to solve questions.
Okay.
Understood? Any
Okay,
more
ma'am.
doubts?
Thank you.
Thank you. Any more doubts? Fine, okay. I'm just wrapping up today's session. Okay. What I wanted you to do is, can you give another example? Yes, Prasanna Venkatesh, for what do you need another example? Okay, I'll give you so more number of questions. Do it as homework. Okay. Calculate mass of 2 moles of nitrogen atom, 0.3 moles of aluminum atom, 10 moles of carbon atom, and calculate number of moles of atom in 10 grams of calcium, 0.1 gram of hydrogen, and 17 grams of chlorine. Okay, this is a homework that I'm giving you. Try doing it on your own. If you wanted the mass of atomic mass of any atom, if you know the mass number, from that you can easily calculate. For the first 20 elements, hope you all know the mass number. You should have studied it in your 9th standard. So just relate it here. Clear? Is that enough? Okay, good. Harit, thank you. Harit. Is that Harit? Harit or Harita? Thank you, Prasanna Venkatesh. Yes. So thank you all. Have a great day. Okay. Finish your homework. And if you know how to upload your homework, please upload it. Okay. Thank you. Mass of in grams per. Remember that. Okay. Thank you all. I'm just ending the meeting now. Okay. In the last session, I'll ask someone to help you with that. Okay. Thank you.